Now what is coordinate geometry? Coordinate geometry means it is the coordination of algebra plus geometry. It is the coordination of algebra plus geometry. Now, how can we combine algebra and geometry? Because we want to solve geometric problems with the help of algebra. If we want to solve geometric problems with the help of algebra, then we can use the concepts of coordinate geometry. It is also called as analytical geometry. In coordinate geometry, we have three different types of coordinate systems. The first one is rectangular or Cartesian coordinate systems. Second one is oblique coordinate systems. The third one is polar coordinate system. Now, this oblique coordinate system is out of the scope of intermediate syllabus, so we need not discuss this. We will discuss only about rectangular coordinate system and polar coordinate system. The first one is rectangular coordinate system or Cartesian coordinate system. Rectangular coordinate system or Cartesian coordinate system. In this type of coordinate system, we will have two fixed straight lines. Those are called x-axis and y-axis. Those are called x-axis and y-axis. This horizontal line is called x-axis and this vertical line is called y-axis. These two lines intersect at the point called origin. This point is called origin. Now, let us say this is a plane. Now, this horizontal line is called the x-axis and this vertical line is called the y-axis. And these two lines intersect at a point. This point is called origin. Now, this is a plane, right? Every surface is a plane. Now, these lines, these two straight lines divide the plane into four quadrants. The four regions are called as four quadrants. This is called quadrant 1, Q1. This is Q2. This is Q3. This is Q4. These two lines divides the plane into two regions, four regions. These four regions are called as four quadrants. This quadrant of 2, 3, 4. Now, if you want to locate any point, this point is represented by two coordinates. These two are called as two coordinates of this point. Every point has two coordinates and every point has two different coordinates. Right? Now, the first coordinate is called abscissa, or it is also called as x-coordinate, and the second one y is called ordinate. It is also called as y coordinate. Now, if we take any point on a plane, it will have individual x coordinate and y coordinate. No two points will have the same xy phase, right? So every point is determined by its x coordinate and y coordinate. We can fix these coordinates of origin. The coordinates of origin are called are 0, 0. The coordinates of origin are 0, 0. If we move right side, then the x coordinate value increases. If we move left side, the x coordinate value decreases. If we move upward, then the y coordinate value increases. If we move downward, the y coordinate value will be decreased. By this, we can tell that in first quadrant, both x and y are positive. So we are moving in this right direction and we are moving in upward direction. So both x and y will be positive. In quadrant 2, we are moving left side and up. So we are moving left side. So x y decreases, so it will be minus. As it is 0, we are moving in left side direction. So x coordinate will be decreased, and we are moving in upward direction. So y coordinate will be increased. So x is minus and y is plus. Similarly, in quadrant 3, we are moving left side and down. Left side means x is minus, down means y is minus. In quadrant 4, we are moving right side and down. Right side means x is plus, down is y is minus. In first quadrant, both x coordinate and y coordinate are positive. In second quadrant, x coordinate is positive, x coordinate is negative, y coordinate is positive. In third quadrant, x coordinate and y coordinate both are negative. In quadrant 4, x coordinate is positive, y coordinate is negative. Now, this is 1, 2, 3, 4, 5. This is also 1, 2, 3, 4. Minus 1, minus 2, minus 3. Minus 1, minus 2, minus 3. If we want to locate a point 3, 3, 1 means x value is 3, so we are going 3 units right side and y value is 1. We want to locate a point whose coordinates are 3, 1. That means x coordinate value is 3, y coordinate value is 1. X coordinate is 3 means from the horizon we want to move 3 units right side. So it is 3. And y value is 1, so we want to move 1 unit upward. So this point is 3, 1. If you want to locate a point minus 1, 3. You want to locate a point whose coordinates are minus 1, 3. You want to move 1 unit left side. You want to move 1 unit left side and 3 units upward because y is positive. So this point is minus 1, 3. Now, if you want to locate a point whose coordinates are 3, 0, there is only x value, the y coordinate is 0. So there is no vertical movement, there is only horizontal movement. So this is the point 3, 0, this point 3, 0. This point is 1, 0, 2, 0, 3, 0, 4, 0. Minus 1, 0, minus 2, 0, minus 3, 0. Every point on x-axis will have its y coordinate 0. Similarly, every point on y-axis will have x coordinate 0 because this point is 0, 0. There is no horizontal movement. So 0, 1, 0, 2, 0, 3, 0, minus 1, 0, minus 2, 0, minus 3. Right. Every point on x-axis will have its y coordinate 0. So general point on x-axis is x, 0. Every point on y-axis will have its x coordinate 0. So the general point on y-axis is 0, y. So that is rectangular coordinate system. Now we won't discuss in detail about the oblique coordinates, but just we will give an introduction about the oblique coordinate system. In rectangular coordinate system, the necessary condition is the x-axis and y-axis are at 90 degrees because we already mentioned one is horizontal line, one is vertical line. So the necessary condition is both are perpendicular. In oblique coordinate system, there is no necessity of any perpendicularity. The two coordinate axes may be in any angle theta. If those are perpendicular, then we can tell that the coordinates are rectangular coordinate system. In oblique coordinate system, the coordinate axis may not be perpendicular, then you take any angle theta. Now, if we want to take any point x, y, we want to find the distance of this x, y from the y-axis and x-axis. Distance of this point x, y from x-axis is y units. Distance of this point x, y from y-axis is x units. Now, how is this possible? Let us take 3, 1. 3, 1 means 1, 2, 3. 1 means 1, 2. Let us take it is 3. 3, 1 means how we are locating? We are moving 3 units right side. That means distance from y-axis is 3. So that is x coordinate. 3, 1. So this point is 3, 1, right? This point is 3, 1. Now we are moving 1 unit upward. 1 unit upward means we are moving from x-axis. So distance from y-axis is x units 3. Distance from x-axis is y units 1. So this is about rectangular coordinate system and oblique coordinate system. So the third one is polar coordinate system. Just to give introduction about this. In polar coordinate system also, we have two different coordinates. Now, what are those two different coordinates? R and theta. Every point is determined by R and theta. Now, what is the value of R? Distance of the point from origin. R means distance of the point from origin. Theta means if we join, let us take one point. This point is at a distance of r units from the origin, and if we join that particular point with the origin, the angle made by the line with the x-axis, positive direction of x-axis, is called as theta. So this point is denoted by x comma y, r comma theta, right? Every point has two rectangular coordinates, that is called as x comma y, and it is also having the two polar coordinates r comma theta. Now what is meant by r? R is the distance of the point from origin. Theta means if we join that point and origin, the angle made by the line segment with respect to positive direction of x-axis is called as theta. It is also called as vectorial angle. It is also called as vectorial angle. Right. Now, if you know trigonometry, this is r sin theta, this is r cos theta. Right. Now, x means what? X means we already told it is the distance from y-axis. So it is equal to distance from y-axis r cos theta. Y means it is the distance from x-axis. So y is r sin theta. If you want to convert any rectangular coordinate system to polar coordinate system, you can use the conversion x equal to r cos theta and y equal to r sin theta. First of all, we were given only polar coordinates. We were given only polar coordinates. By using this relation, what can we tell? X square plus y square equal to r square. Cos square theta plus r square sin square theta. By this we can tell x square plus y square equal to, if you can take r square common, cos square theta plus sin square theta. So x square plus y square equal to r square. It is the relation. If you divide these two, then what happens? X by y equals to cot theta, or tan theta equals to y by x. So theta equals to tan inverse y by x. There are two types of problems in this concept. First, you will be given r value and theta value. These are the given values. You want to find x and y. How to find x? X equal to, we know this value r, we know this value theta. If you know theta, we can find cos theta. So x equal to r cos theta. Similarly, y, we know r value, we know theta value because they are given r sin theta. The second type of problem is x and y are given, we want to find r and theta. What is the r is? R, we know r square equal to root of r square equal to x square plus y square. As x and y are given, you can find x square and y square, then you can sum them. So r equal to root over x square plus y square. What is the formula for theta we are having? Theta equals to tan inverse y by x. As x and y values are given, you can find y by x and you can find the tan inverse of it. So this is about polar coordinate system. The next concept is distance formula. What do you mean by distance formula? In distance formula, we want to find distance between any two given points. We want to find the distance between any two given points. Let us say this is the point x1 comma y1 and this is the point x2 comma y2. Let us join these 2 points. We want to find the distance between those 2 points. Now, distance of this point from x-axis is y units. Here, what is the value of y? y1. Now, similarly, distance of this point from x-axis is y units. So, this total is y2. Similarly, distance of this point from y-axis is x units. So, this total is x2. Similarly, the shortest distance of this point from y-axis is x2. This is x1. Right. Now let us join these two. This line is perpendicular to x-axis because we are measuring the distance from x-axis, so it is perpendicular to x-axis. It is parallel to the axis, so this is at 90 degrees. Right. Up to here the distance is x2. Because up to here the distance is x2. Up to here the distance is x1. So this distance is x2 minus x1. From here to here the distance is x2 minus x1. Up to here the distance is y2. Up to here the distance is y1. This is y1 and this is also y1. This total distance is y2. This total distance is y1. So this distance is y2 minus y1. Now this forms a right angle triangle. Now in this right angle triangle, the hypotenuse is equal to hypotenuse. Let us take this point is A, this point is B. The distance AB is equal to root over side square plus side square. So the hypotenuse is the distance we want to find. That is equal to root over this side. The side value is x2 minus x1. That square is x2 minus x1 whole square. This side is y2 minus y1. So it is y2 minus y1 whole square. So distance of these points x1 comma y1 and x2 comma y2 is root over x2 minus x1 whole square plus y2 minus y1 whole square. We are finding the distance. Distance which is related to geometry, but we are using the concept of x and y. It belongs to algebra. Square means it is in the form of a minus b whole square. A minus b whole square it again belongs to algebra. So we are solving geometrical problem with the help of algebra. So it is the basic concept of coordinate geometry. Now let us find the distance between the points 3, 5 and minus 4, minus 1. Now this is the point x1, y1. This is the point x2, y2. What is the distance for the distance from y is root over x2 minus x1 whole square plus y2 minus y1 whole square. Now substituting the values. x2 is minus 4, x1 is 3, y2 is minus 1, y1 is 5. This is minus 7. Minus 7 square is 49. This is 36. So this is root 85 units. The distance between these 2 points is root 85 units. There are some more different types of problems using this distance formula. We will be given 4 different points. Let us take 1, 0, 3, 0, 3, 2, 1, 2. We will be given 4 different points and we want to verify whether this will form a square or a parallelogram or a rectangle or rhombus. Now let us find the distances. Let us take these points as A, B, C, D. Right. Let us find the distance AB. AB is root over x2 minus x1 whole square plus y2 minus y1 whole square. 3 minus 1 is 2, 2 square is 4, 4 plus 0. So it is 2 units. Similarly BC 3 minus 3, 0 square plus 2 minus 0 square. So it is again 0 plus 2 square 4. It is also 2 units. CD is again 1 minus 2 is square plus 2 minus 2 whole square. Again we will get minus 2 square is 4, 4 plus 0. It is again 2 units. DA is 1 minus 1 square plus 0 minus 2. It is again root over 0 plus minus 2 square is 4 units. So we have find the distances of AB, BC, CD, DA. Right. We got all the 4 sides equal. It may be rhombus or square. How can we find whether it is a rhombus or a square? We want to find the diagonal lengths also. Let us find the diagonal length AC. 3 minus 1 root over 3 minus 1 square plus 2 minus 0 square. So it is 6 square 4 plus 2 square 4. So it is root 8 units. Similarly, we want to find the length BD. Root over 1 minus 2 whole square plus 2 minus 0 whole square. It is again 4 plus 4. It is also we are getting root 8 units. We got the diagonals also same. If the four sides are equal to each other and the diagonals are also equal to each other, means the 4 points will form a square.